Alright, we've got battery 2C, surge impact driver, everything's hooked up. This meter is measuring J1 next to the positive power pin, yellow lead, which is yellow on the scope. This multimeter is measuring the J2, which is the ground side pin, and that is blue on the scope. Alright, hook up ground, and when we hook up power, we'll get light on there, but we get nothing. If I do my little, yes, it does work. So you can bridge the positive and J2 to get power, but nothing there. So battery currently has no voltage on any of its pins. Okay, so we get a very small voltage, 5 millivolts on tool. Okay, so we've got nothing on the scope. We'll wait for the scope to get back to the start of the screen and boom. Ah, I missed it. That's a shame. So, blue stays high, 3 volts, and we're just going to time how long it takes. It takes like a minute and then it drops back. Oh, I think it's like 3 or 4 minutes actually. Something I need to do is measure the quiescent current. That was a weird little change in the thing. So the weird thing is, green on charging is the charger talking to the battery. When it's battery to tool, green appears to be battery to tool. And also, green was 12 volts on the charger. I guess the battery is incapable of putting out more than 3 volts. I think there's no amplifiers, it's just the UART pins from the MSP430. So it can only output 3 volts, but it can accept higher voltages as input. Oh, I went a bit too fast. Okay, so yellow gave us a pulse of... It's a pulse of, looks like 20 volts. So it just gives the full voltage back. And the duration, I was hoping to measure the width of that pulse. I might have to get it on trigger. Although, will we necessarily even see a trigger? Whilst that's holding high, I don't think we'll see a trigger on yellow. Do see moderate amount of noise. So yeah, 0.3 of a volt noise. Crank it up, full speed. Okay, I thought it might be a lot noisier. The startup is certainly noisier. About 1 div. Oh, okay, so that's quite a lot of noise. So we're getting nearly 2 volts of noise there. So that's giving us noise of 1 volt on a 3 volt signal. That's 23 volt noise on yellow, which basically means you cannot signal on that pin. Alright, we're going to try and capture the starting pulse, which is yellow. And so they're currently, both pins are on 0. Yeah, 20 volt pulse, which is going to be what the pack is. It's just feeding back the same thing the pack. Okay, duration of the pulse, the most intuitive thing, but it was cheap. And it does a decent job. It's nice and convenient too. Okay, so a 22 millisecond pulse. The first pulse is maybe a millisecond and did not achieve anything. But after that, the 22 second pulse, it clearly does it before it, drives us up to 3 volts. Alright, I'm just going to try and capture a few more start pulses. Try and see what the width is. Also 22 milliseconds. We get this weird little pre-pulse. So, when blue is high, we don't get our startup pulse. We're just getting the noise, basically. So I don't know if I should sit around again and wait for this thing to drop down. I'm going to time it because I want to know what this is. I'm going to hold the trigger. There. Well, there we go. 2 minutes 45, I'd say. Alright, start pulse again. This time we're triggering off blue. We're going to trigger blue at 2 volts. It seems to be a pretty consistent 22 milliseconds. So there's a zoomed in one. I'm pretty sure it's 22 milliseconds. That's measuring from the start of the rising edge to the start of the falling edge. Okay, hopefully this works. It's running. Alright, I have disconnected the green/blue lead. See a different behaviour here. Yellow, when we pull the trigger, yellow pulls high. So the tool is bringing yellow high to the battery, and the battery is replying with blue high, but then it stops pretty much instantly. I'm guessing because it's detecting that blue is open circuit, and so it just brings it back down. And yellow stays high for as long as I hold the trigger. So for as long as I hold the trigger, it holds it high because it's not detecting anything on the tool's J2. So it's going to hold that high until it gets that voltage on it. Let's do it with my fingers. Nope. Bloody hell. No, okay. It doesn't work while I'm holding the trigger. Yeah, weird. There we go. Okay. So the tool brings yellow high, or J1 high, and then 20 milliseconds later, the battery brings J1 high. And it brings J1 high for 20 milliseconds. They seem to like 20 milliseconds. And it detects open circuit and says, stuff you mate. Alright, we're going to try. So again, we've got green disconnected, and that will just give us this behaviour. The battery gives a pulse, but after 22 milliseconds, it detects open circuit, brings it back down. Now, so I've just got a 1 mega ohm resistor to ground. So we're going to see what happens. See if that can trick the battery into thinking it's got a connection with the tool. Let's hope we don't blow anything up. Doesn't seem to like it. No. 1 meg might be too much. No. 100 kil is still too much. This may not work at all. I could be completely wrong about how this all works. This may seem like a waste of time, but it's important to know how to trick the battery into staying active. Ooh, what happened then? We're only getting a half volt pulse. That's bizarre. 10 kilo ohms. Gives us a half volt pulse. See, we need a way to give it the pulse, give it that, and make it stay high. we could be exceeding whatever the current of the UART is. So 10 is too low, 100 is too high. Do we go in between? Or do we think that we're just completely off the right track? 47k. Nothing. What the? Oh, that's 4.7. I need 47. Duh. Well, we're getting a bigger pulse. How does it know that it's open circuit? Something else to it. Has the battery got some other detection going on? So we're giving the battery a 12 volt pulse. It's giving a pulse, but then it's not going. If it's connected to the tool, it does, but that could be entirely related to current flow. It goes high and stays high. There must be some other current detection, like, is it detecting current flow through the battery? And unless you get current flow in the battery, then it doesn't hold high. I forgot what I was going to test after this. Okay. 1 mega ohm from high in there. Whoa. See, now we pulled it up. All we've done is boosted that by 0.9 volts. That does not achieve anything. Okay, we are going to run the impact driver and see if it periodically sends a pulse. I am skeptical, but we need to know. Okay, so we're going to run that for 3 minutes and see if there's a pulse around about the 3 minute mark on the yellow line to reactivate the battery. If not, I think what's happening is the battery is actually detecting current. It'll be interesting to know what its minimum current detection is. Alright, I don't think there was a pulse in there. I'll have to check back later. I'm going to see what happens when I disconnect yellow while the tool's running. Doesn't make a difference, as you'd expect. What happens when I disconnect green? Okay, I'm going to try and manually pulse this. Trick the battery into activating this pin. So if we give it a pulse, ooh, we're getting that. So this is us manually giving 20 volts to yellow, whereas the tool gave it a bit less than 20, like 19 or 18. But then it dropped straight back down, so we're not activating the battery. The battery can sense that nothing's going on, and it just brings that back down. So we're going to try putting a 100 ohm resistor across the contacts so that there's current flow through the battery. 0.2 of an amp. Let's see if that can trick it. Nope. This will be giving us roughly an amp. So if this doesn't work, then we're on the wrong track and we need to try something else. It could also be the timing. I may have to connect the current at exactly the right time. Doesn't work. Is it timing related? This will be super difficult if I've got to tap them at the same time. Oh, hang on. We've done it. We somehow activated the battery. Battery is high. The annoying thing about these tests is you've got to keep waiting for the battery to reset itself and go back to sleep. Ah, there we go. Okay, so it finally reset. I swear that was a much longer reset than normal. Right, so pulse, manual pulse. Oh, interesting. That's very interesting. That's so bizarre. I'm gonna have to try that. So this is a different thing. So just giving it lots of pulses on that. Oh, maybe it's detecting the noise. So it sees, maybe it needs 4 pulses, and then it's sort of taking advantage of the noise on this pin, on the noise that comes in yellow from the tool running to activate it. One, two, three. Nope. 1, 2, 3, 4. There we go. So just giving it frantic taps seems to activate it. Okay, so that was 2 minutes 35 or 2 minutes 40, I think. Let's try this anyway. I don't think it'll work. So we've got yellow connected to the load. So this is going to simultaneously give a pulse to yellow and put load on the circuit. Doesn't work. So it's not to do with power draw. I believe it's to do with noise. So if we just touch it, nothing happens. If we scratch it around to try and induce noise, I might have to go onto the tape. It works. Gets it to trigger. I think maybe the duration of the pulse needs to be a certain length. Okay, so my thinking is that it's the duration of the pulse that wakes the battery. A long pulse doesn't wake it up. So here's long pulse, doesn't do it. I think what you need is a very short pulse. Nope. Oh, there we go. So, I need to go look at that video and figure out what happened. So, pulse. Nothing happens. Let's give it a really quick pulse. Nope. There we go. It might be the duration, but how does it know? Oh, maybe. That was a 30 millisecond pulse. I wonder if it's... I really need to measure the duration of the blue pulse. I think probably what happens is the blue one pulses, and what you need is for yellow to drop before blue drops, and then blue stays high. I think that's what's happening. Alright, we're looking at duration of the pulse. I think what happens is the pulse needs to be 20 to 40 milliseconds. So, are we running? No, we're not. What's going on? Run. So if we do a long pulse, it doesn't stay high, because what it's looking for is for yellow to drop in under 20 milliseconds of this coming up. I explained that badly, but anyway. Yellow comes up, 20 milliseconds later, blue comes up. 20 milliseconds later, if yellow is still high, blue comes low. Now, the tricky one's going to be, can I get a really short pulse? So yes, after 20 milliseconds, yellow was still high, so blue came down. And that was a, let's see if we can get a super short pulse. Didn't quite pull it off. But yeah, here we go. Blue comes up, and within 20 milliseconds, yellow was down, so blue stayed high. So, don't know if... What I really need to do is try and make a sub 20 millisecond pulse and see if that will do it. Alright, where are we? We're going to try to do a short pulse. Okay, 4 milliseconds. I don't know if you can see. I might move the camera so you can see what I'm doing, because it's pretty dumb. But I am just whipping the thing. Alright, we're running, and 4 millisecond pulse does not activate the battery. Ooh. 20 millisecond pulse doesn't work. So it's got to be between 22 and 44. We're testing what voltage we need to put into the tool in order to trick it into run. We're going to wire up power from 2 amp hour battery, but we're not going to wire up anything else. We're going to... So there's our power, we've just the power connected, and it won't run. We can bridge it with our fingers to make it run. But let's see what happens when we put power supply into it. Oh, wow. Oh my lord. That's insane. I thought it would have to go to at least like 2 volts. 0.2 nothing. 0.4 nothing. 0.5. 0.7. Wow. 0.7 is all it takes. What happens if we ramp it up? Nothing. Now the interesting is what happens when we take it down. So we're going to floor it and drop the voltage and see what happens when the cutout point is. .6. And I'm pretty sure we can hit it with like at least 12 volts. Doesn't seem to be any discernible difference. I couldn't hear any changes in RPM, so it's not like it has any sort of analog effect, but we'll have to test that a bit more thoroughly. .71 doesn't seem to work. .75. 7.2. .725, not enough. 727. Yeah, 727 I think is the answer. Alright, we have changed things around. We're going to be measuring the current coming into or out of these pins. Blue meter is going to be measuring the current through J2, the ground side pin. Yellow meter is measuring J1, the positive side pin. No current through the pins. No voltage on the pins. Residual. Alright. That looks pretty definitive. We've definitely got something there. So, yellow, which is the tool pin in this situation. They seem to be flipped. And is it minus 5 amps? Yeah, so the current is flowing from the battery to the tool. I'll just double check. Is it the same on low speed? Okay. The current sent is somewhat proportional to the power consumed. We've got the blower hooked up this time, so 1 amp gives 1.2 microohms. So that was about 4 microamps to 2 amps. Did we learn anything? I don't know if we did. Okay, I just noticed a voltage change in blue, ground side 1, just J2. 3.174, it drops down to like 3.07 when the trigger is pulled. This goes up to 0.62 and off. Now, keep an eye on that, because I think at about 30 seconds that jumps from 3.05 up to 3.15. This is also a very small voltage, 5 millivolts. I wonder if that changes. I think there's like a 2-stage hibernation you do. Oh, there we go. 40 seconds, that jumped up, that dropped to full zero. So 40 seconds, this goes from 3.05 to 3.175, and that went from 5 millivolts to 0. So it's like a 2-stage shutdown. There we go, 2 minutes 49. Yes, and that comes up to 3.1. Well, I can't actually stop this test because I need the battery to reset itself in order to do the next test. That's wacky. Oh, there we go. Like 5 minutes 14 or something. Okay, 2 minutes 50-ish. Alright, we are going to try and activate the battery and keep it on using power supply. So the theory is putting 6 volts into that pin will keep it awake. We need our pulse to try and get this active. Not going to happen. We need to go higher. Okay, so 1 volt is not enough to get it to work. Nope, 2 volts is not enough. 12 volts. 13 volts. Something happened then, but I just couldn't see it. Okay, 13 volts seems to have woken it up. There we go. We're going to say 12.5 is our minimum. 12.6. Oh, that took it high. Okay, so I think 12.6 is enough to get it high. There we go. Need 12.7 volt pulse. Now I'm hoping that I'm just going to leave it 12.7 for now, that the 12.7 into J1 will keep this alive forever. So we're going to have to wait for like 8 minutes to see if it actually works. Okay, 2 minutes 34, it deactivated. So 12 volts doesn't actually do it. It did not keep it awake. Alright, we're going to see what happens when we can disconnect J1 while it's running. Ugh, it's going to be a bit painful. We'll just start that now, because why not? Okay, we're back after running out of memory card space. We're up to 8 minutes or 7.5 minutes of running without disconnected. So we're going to turn it off, restart the timer and see how long it takes to deactivate. So fairly sure that this doesn't keep it awake because that was like 8 minutes of running without that connected. Okay, 5 minutes too. Alright, we're testing what's the amount of current that we can get out of the J2 pin. This is measuring the voltage at J2 and this is measuring the current through it. Well, it's measuring the current back to ground, but same thing. We're going to tap this until we get 3 volts. Yep, we've woken the battery up. Now this is a 1 kilo ohm resistor, and I'm pretty sure it's going to kill the voltage. 3.2, and it absolutely plummets. So 1 kilo ohm, no bueno. 3.2 volts, 10 kilo ohms. If it didn't sag, would be giving me 300 microamps, I think. But we only get 54 microamps. Okay, 100 kilo ohms should give us 30 microamps if the voltage doesn't plummet. Voltage doesn't massively plummet. 1 mega ohm, which should give us 3 microamps. Yes. So, realistically, 3 microamps is the most you can get out of that pin. Well, I mean, it could reasonably do 21 micro. We shall see. We have a 200 ohm resistor, so it connects it up to 20 volts, will give us 0.1 of an amp, and we're going to test if that is enough to keep the battery awake. So this is measuring voltage on J2, and this is measuring current. So we'll hopefully see 100 milliamps here, and then we're going to be watching this to see if it goes back to sleep. And it's going to take a while, a couple of minutes. Tappy tappy tap, 3.2 volts, we're awake. Let's connect our resistor. 89 milliamps. Oh, we've lost it. Okay, so that did not keep it awake. Alright, testing again, but with a 20 ohm resistor. There we go. Alright, we're coming up to 2 minutes 20, which is going to be about 2 minutes 40 since we woke the battery up. Got to give it the full 8 minutes, I think, to be sure. I'll be happy if it does work, because if it doesn't work, I'm not sure what to test next. Alright. So the other one I've seen is 5 minutes. 5 minute shut off. Now, the problem with this, if it does work, I've got to drop it down and try and find out what the limit is. At what current. I think I'll have to swap the battery over as well because this one's nearly empty. It's down to 1 bar. If it does work, if it does go beyond 8 minutes, I might just let it run down. I want to see this thing switch off for undervoltage. Okay. I don't know if that's going to be visible, but that's the pack voltage. 17.9 volts. Gone past 5 minutes. This may have actually worked. How's our temperature? 127. Good thing I put it on the silicon map. That. I don't know if that'll be visible, but she's damn hot. Coming up to 7 minutes, which is going to be like 7 minutes 20 since we woke it up. I'm getting fairly confident that this 800 milliamps is enough to keep it awake. Alright, coming up to 10 minutes, and it's a bit over 10 minutes because we started the timer after. So it looks like, I think that's pretty much confirmed, that you need current draw through the main pins, and it's sensing that, and that's what keeps this awake. So let's reset, disconnect as we start the timer, and hopefully at 2 minutes 30 or 5 minutes or whatever it is, we will see that drop down. If it doesn't drop down, then I've done something really crazy and made it stay forever awake. There we go. Just short of 5 minutes turned off. Okay, same test, but this time I'm going to drop the current down a bit. Wake the battery up. There we go, 3.2 volts. Okay, 400 milliamp. Just did a funny little flick up then. Went above 3.2 and then dropped to just a bit below it. It's like a 10 millivolt change. Okay, we've got out the electronic load battery tester, and we're going to use that in order to test our thing. Got it set at 500 milliamps. Let's see if 500 milliamps is enough. Get the stopwatch in there and play the waiting game. Oh, and we've lost it at 7 minutes 40. Okay, weird. Alright, we're going to try if 1 amp is enough to keep this awake. So we've got our programmable load. There we go. Battery's awake. Power up. Alright. So this is pulling an amp. So that's 11 minutes and still going, still active. Alright, we're trying to keep battery 2C awake with 600 milliamps. It's awake and start. Alright, keep awake test. We're going to go for 700 milliamps this time. The pin never dropped. This is going to cut out pretty soon. I'm thinking 11.5 volts and it'll be gone. Oh, hang on, we lost it. Yeah. Okay, this is battery 5B. It's my newest battery, made in 2021. Okay, we're testing 5B with no load at all. Okay, 2 minutes 38 roughly. Alright, testing battery 5A, 2 amps, wake it up, we're awake, go. Okay, coming up to 10.5 minutes, that's when it shut off at 1 amp. 25 minutes, still awake, that'll do pig, that'll do. Oh, there we go, shut down at about 29:10. We've got 12 amp hour. This has unusual behavior in that it falls asleep after about 8 seconds. Let's wake it up. Tappy tap. Okay, it's awake. It's about there. 1, 2 screen. And down. It's about 8 seconds for it to fall asleep. So it's the only one so far that puts itself to sleep quickly. It's 8 seconds as opposed to about 3 minutes. And the other thing it does is it wakes itself up if you draw current. So 40 milliamps does not activate this battery. Coming up to 100 milliamps, not activating. Oh, there we go. So touch over 100 milliamps, it will activate. And we get this weird little negative pulse every 7.8 seconds or so. So if we drop it down, so below 100 milliamps, it drops and stays dropped. Above 100 milliamps, it comes up and stays up. What I want to see is what current makes it stop doing this behavior. Because what happens is it stays awake for just under 8 seconds, and then it puts itself to sleep, but then it instantly wakes itself back up again because it's detected over 100 milliamps. 1 amp is more than enough to keep it awake. It's doing under 400 milliamp. Let's go down another one. 300 milliamps. I can't remember what we did on the way up. There we go. Okay, so under 300 milliamps gives us our down pulse. That looks good, it's holding high. Do we go for tree 50? Is tree 50 going to be the magic number? Alright, we're under tree 50. There we go. Alright, so 320 milliamps. Alright, we're measuring the pin current of the 12 amp hour, because previously we only had the current of the 2 amp hour. What was that? 54 and 0.56. Hey Tiger, wake up! .15 and 21. 3.04 and 2.95. 2.56 and 13. Okay, we're testing the high output 6 amp to see if it can wake up from current alone. Okay, not waking up, and it's actually driving the pin negative. Yeah, as our current increases, it just makes this pin more negative. So nothing going on there. This one will not wake up until you tap this guy. There we go. Testing all tools on a 12 amp hour battery. 12A. We're going to activate this battery. We're awake, and then now it drives the LED, and when it pulls low, the LED will turn off. It's awake, LED is on. When the battery pulls J2 low, then that goes off. We're going to activate the battery, brings that high, turns on the MOSFET, turns on the LED. Now if we connect, if we bridge the thermistor with 8 kilo ohms, nothing happens. But if we bridge it with 6.9 kilo ohms, it dips, we get our warning LEDs, and the battery won't respond to activation requests until the warning light goes away, the thermal overload. Dip that down again, same thing, LED goes off, we're in thermal, won't respond to the pull. Now it's active, and it comes back. If the tool, whilst it's active, pulls J1 high, it has no effect on J2. If the tool pulls J1 low, it has no effect. J1 will just bounce back up as soon as you remove the load. So I'm grounding J2 and it just springs right back as soon as you remove it. So we've got J1 only connected to the tool. So we get a pulse from the tool, but nothing happens at the battery. So we're going to hold the trigger on and manually start the battery, wake up the battery. And then it works. The battery didn't wake up. There we go. Battery's awake, but tool didn't run. I let go of the trigger. Now the tool runs. So what we're seeing is that the tool does not bring J1 low. The tool keeps J1 high. So it's actually the battery that pulls J1 low and creates our pulse. And if we touch that, we can make blue J2 go high, but J2 going high, even though that's feeding into the tool, does not make J1 go low. So the tool does not detect the pulse and make J1 go low. The battery is doing it all. The battery makes this pulse and also pulls J1 low. If we get the tool running and then cause an overheat, we can see the timing between J2 going low and J1 coming high. Overheat. It's like 200 milliseconds. Okay, we've just figured out that the tool brings J1 high when J2 is disconnected. Disconnect J1, tool keeps running, so the tool is not holding J1 high and relying on the battery to pull it low. Once the battery pulls J1 low, the tool stops pulling it high. Now, if we can disconnect J2, the tool brings J1 high. This measure is measuring J2. This one is measuring pack voltage. It will not. The battery has decided that it is flat and it is not going to run. Even though it's recovered to 16 volts. Once you've triggered that low voltage protection, it's like, nope, I'll have none of that. No, it's a blower thing. So this is going to be measuring the current, and this is measuring the voltage between the ground pin and the CT1 pin. So with the trigger held down, normally J1 stays high, but sometimes it comes low. Okay, so it seems there's a time. And when J1 is low, if we send J2 high, then the tool will start. J1 high. Let's just time that. And it's being held at 14.3 volts. Okay, J1's come down after, well, that's saying 30, but now the tool will start. Trying to measure the resistance again between CT1 minus, between the ground pin and CT1 minus. That's the resistance to the ground rail. That's measuring the voltage across the ground rail, and that's measuring the current. Alright, we're measuring the resistance of CT1 minus rail on a 12 amp hour. .20 millisecond down pulse and a 10 millisecond up pulse, which I think it goes down 5 times and then comes up a final time. Blue is the enable pin, yellow is the pack voltage. There we go. That's pretty trash, isn't it? Alright, we've got a 1 ohm resistor in the form of some wire. Hopefully nothing will happen when I connect this. Alright, got no current, that's good. J2's awake. And then we're going to connect J2 and watch the current. 20 amps and we're smoking. When we connect it, we get 18 amps. Remove it and it loads gone. Wakes up and gone. Alright, we've halved the length of the wire here, so it's going to be about a bit less than half an ohm. connect this and hopefully nothing happens. No current, that's good. It's not quite as exciting as having something light up, but yeah. Let's wake up J2. We're awake, and 30 amps, and it's glowing. That was hot. That went hot real quick. Wake it up. We're awake. Activate. 30 amps. Red hot. Whoa. Wake it up. Activate. Hits 35 amps to start with and goes red hot. Drops down to 25 amps, presumably that's increasing in resistance. So J1 not connected, J2 is just shorted from positive to the J2 pin on the tool so that it'll run. No effect. The bringing J1 high does not stop the tool, so it appears that a high signal on J1 is coming from the tool, not coming from the battery. And action. 60 amps, 56 amps. Alright, might have to go a bit shorter. 60 amps. How are we doing? Oh, we've set fire to our elastic band. And 75. Whoa, whoa. Okay. I was worried about that. Hot, 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 hot. Way. Okay, that's about to melt through. It has melted through. The wire got very thin there. Nearly melted right through. Safe-ish to touch now, but yeah, that piece there was not going to last much longer. Alright, we're trying again with some new wires. 69, 58. Okay, that holds up a fair bit better. Oh, there we go. 65. Alright, looks like we can get a solid 50, 60 amps. Okay, we're going to try and drive 50 amps through this wire and then turn it off by thermaling with this resistor. There we go. Alright, 60 amps. Let's let it get red. 50 amps, and then let's give it the resistor. And we get thermal shut off, just as we wanted. You can see the LEDs giving us thermal. It's awake. 60 amps. We'll let this get hot enough to see. 55 amps. Oh, I can feel the heat coming off it. Alright, let's give it a thermal. Now, there we go. Do it one more time. Right, we're on. 58 amps. We're going. We're going to give it a resistor right about now. Turns off, turns off. There we go. So we're controlling 60 amps and it's got over temperature protection and low voltage.